Hey friends, today I'm going to work on a heating chamber for my black soldier flies. So I'm working in this basement in the wintertime in Pennsylvania, so it's actually too cold for my black soldier fly larvae to do their job. So I'm going to make a heated chamber, and when I was thinking about it, making a heated chamber for black soldier fly larvae is exactly the same as making a still air incubator for chicken eggs. So I thought maybe I could kill two birds with one stone. We can talk about how to build a chicken egg incubator and how to make, and at the same time I'll end up with a warm place for my black soldier fly to pupate. So let's get started. So I went to the hardware store and I got some foam board insulation. This is 1 inch thick. It has a R value of 5. It's just a 1 inch thick foam, and it comes in 4x8 sheets. You can use whatever insulated foam you can find in your area. If you can't find insulated foam, you can always make a wooden box with another wooden box that fit inside of each other, and you can stuff the area in between with any kind of foam you can get. You can get some foam that's used in pillows or mattresses, or some foam that's used in upholstering couches. You could fill it with coconut husk, you could fill it with ground up peanut hulls, anything you can do to get an airspace. So how you end up with an insulated box is up to you. You could even use an old cooler, you could use an old chest freezer that doesn't work anymore, if you have one lying around. So it really doesn't matter what you use for your insulated box as long as you want to make one. So I'm going to make this here. I'm just going to cut it up and glue it together. We'll save you on that part, and then I'll show you how we do the electronics when I come back. Hey guys, I'm back, and I've got a basic box here. Lid's just sitting on at the moment. So I tried to glue this together, and I wasn't sure if the glue was going to hold, so I put some screws in it. So now I've got a basic box. This box happens to be 2 feet by 4 feet by 1 feet high in imperial measure. I'll put the metric right here. So now that we've got a basic box constructed, simple glue and screw is good enough for this. Don't worry if it leaks air. Black soldier fly larvae and chicken eggs all have to respirate anyway, so we need to have air coming in and out, or else they'll suffocate. Both of those creatures create carbon dioxide, so we'll need some way for air to get in and out of this incubator space anyway. This is a really big incubator, so I want to put 3 bins worth of black soldier flies in here and keep them warm. If I was doing an egg incubator, I would probably only go maybe 2 feet by 18 inches. If I just had maybe 12 chickens and I wanted to put a dozen or so eggs in here. The bigger it is, the harder it's going to be to heat. Chickens are going to be a lot more fussy. Chicken incubation is a lot more precise an endeavor, so it's a lot easier to control a smaller box. Also, chicken eggs, I might make this a little bit shorter. I made this a little bit tall to accommodate the bins and then the height of my heat lamp that I'm going to stick in here. So let's start looking at how we're going to wire this up. So here's what I'm going to be using for my heating setup. This is a ceramic heat lamp. If I were in Africa, I would probably just either use 100-watt tungsten light bulbs, or else I would use a brooder lamp, the big red brooder bulbs. And I have this ceramic socket for that we'll screw in if we're careful. So basically I want to suspend this basically in the middle. Because this is a still air incubator, I want it about in the middle. If I was going to do a forced air incubator where there'd be a fan blowing across this, I'd want it on the edge, and I'd want to blow the hot air this way, and I'd want to have some kind of escape over here for the air to come out. But since this is still air, I'm going to put it here in the middle. If you're doing like chicken eggs, you'd probably want your chicken eggs off to one side, and you'd want this off to the other side. You don't want this directly over your eggs because it may cook them. even if the average air temperature is good, something directly underneath it might get too warm. So like I said, in this case, we're going to stick it in the middle and then have our lid over top. So I'm going to start thinking about how I'm going to implement this, and I'll get back to you. Alright guys, so I decided for this I'm going to do a symmetrical design. So I'm going to have a little bridge here in the middle, which I'm going to use to hang my light, and I'm also going to use this for a location to mount any of the control system stuff that we'll talk about in a minute on. And then I'm just going to have a door on each side, one here and one here, and I'm probably just going to hold it in barbecue skewers. It's going to be like a nail that you can pull out with your fingers. Easy to put in, won't come off on its own, easy to take back off. So right now what I need to do is I need to create a hole so that we can mount this guy here in the middle. The reason I did that is since this is a still air incubator, this thing's going to be giving off heat, and I'm going to have my two tanks of black soldier flies on each side. You might be using eggs for incubation, you might have your eggs on either side. In the middle you can leave for your humidity tray. It's usually nice to have your water trays right underneath your heat source so they help create humidity better. And then you can control the surface area of that water to control the humidity in your bin. You'll need something to monitor the humidity with if you're going to make an egg incubator. Here's an example of a hygrothermo. So it's just a hygrometer with a thermometer. And this will tell you the percent humidity, and it also gives you a temperature reading. Right now it's saying it's about 55% humidity in here, which would be fine for the setting turning part of incubating eggs. But anyway, you can put this in your incubator somewhere where you can see it, and you can use that to say, oh, do I have a humidity problem or not? So there's a useful gadget. I'm going to cut that. Maybe I'll put it back in. So right now what we need to do is we need to drill a hole so we can suspend our light here in the top center. So I've marked the center of this little bridge that I've made. This bridge is screwed in place with 4 screws. And I'm just going to drill a hole in the middle here so we can stick our light through and have our wires coming up to the top. So as you can see, I just took a hole saw with the appropriate size, drove it right through. Now I need to see if I can push the foam out of my hole saw. Tends to get stuck in there. We'll do this off camera. So you can see we have a little plug here, and now we can test fit our lamp and make sure that our lamp fits in here. I'm using a little ceramic lamp because it's not going to melt if it gets too hot. So the way we'll do this is we'll bring the wires up through here, and this has a little bit of a loose fit. What I'm going to do in this case, since we have this metal bracket, is I'm just going to stick 2 barbecue skewers through there, and I'm going to suspend our light that way. That way if we ever want to roll it out, we just pull out our 2 skewers and we'll be able to go for it. Little note on safety. I'm taking some shortcuts here. Obviously I'm having some exposed electrical bits on the top. If you're going to do a more permanent setup, or if you have little kids running around, you definitely want to put all your electronic parts covered in some kind of box to keep people from touching anything that could shock them. Anyway, I'm going to move on to the next part here, and we'll be right back. Hey friends, I'm back, and I've made our lids. So first, I just took a little bamboo skewer, basically a stick, and I made a little toggle that I could put through this electrical component that holds that up without it falling through. And if I want to take it out, all I have to do is remove the stick. I have to put the stick back in, and we can be back to business. So that's pretty simple. And then I was thinking about a way to make the top stay on, and I just came up with these bamboo skewers. Basically just long wooden nails. It's just a sharpened stick, really. So if we want to open this up, we can take those off. we can get inside of our box. And then we want to go back in and just put our skewers back in, find the hole that they were in before. So pretty easy to do. Next thing I want to do is I want to put a window on each lid. So I'm just going to cut out a hole in here, square hole, and then I'm going to either glue or screw this piece of plexiglass down on top of that, so that I'll have a way to look in and see what's going on, make sure everything's okay. So that'll be the next step. So I'm doing all this with a razor knife. Not really doing it on camera 'cause it's kind of boring. So like for this, I'll make a cut probably about a square about an inch smaller than this material, and then this will go on top and there'll be glue there. But to cutting, I'm just using a razor knife for this. If you're making this out of wood, obviously you're going to need different tools than I'm using. But like I said, right now we're just working on a box. As soon as I get the box finished, then we'll look into some more electronics. Alright, let's get cracking. So I got my windows installed. I cheated a little bit. I had a piece of 1-inch angle iron, so which is about 25 millimeters. And so I just drew, I traced the glass. It's actually plexiglass in this case, it's clear plastic. And then I put my angle iron in, so I have an offset of 25 millimeters on each side, and then I cut that out with a hacksaw blade. I just made a little cut with the knife and then stuck the hacksaw blade in and cut along my edges. And then I just attached it with some super glue, and that worked really well. It's a little bit messy, I've got foam everywhere to vacuum up. But now I have lids on each side. I can open up this side, I can pull the pins, I can open up the opposite side. And then when I want to put it back together, it's just a matter of sticking my skewers in their holes. So she's all buttoned up. I have a window here and here on each side. Flip this up so you can see. Some of my tools are inside. So I've got two windows so I can look in. So the way that I'm going to configure this is I'm going to put the thing that I want to keep warm on this side and on this side, and then all my controls will be in the middle, and then also any humidity trays that I want to put in will also be in the middle under here, because you won't have to get at them as much. So if we're using this for an incubator, you're going to have to turn your eggs 3 times a day. Still air incubator, this design has to turn the eggs by hand. So, before breakfast, at lunchtime, and before bed, you'll have to open this up and you'll have to turn each of your eggs. It might also be good to reposition eggs from one side to the other. Another thing about hygiene, foam, if it gets messed up, if you use foam, it's not very easy to clean, so it's not super hygienic. So I would suggest doing what I'm going to do with mine, even though I'm not actually doing chickens in this one, and that's to keep your eggs in a plastic bin, so that all the mess from hatching and everything can easily be removed, and that part can be cleaned. So as long as the chicks are never actually roaming around on the foam, it should be pretty easy to clean up and keep your incubator clean. One thing to be concerned about is splay foot. So if chicks hatch out on a smooth surface, they can't keep their feet under, the feet spray out. In the first couple hours of their life, their legs are still kind of rubbery and they can stay fixed like that. So if you do use some plastic with a smooth bottom, you might want to put some grit or some sawdust or something in there that chicks can really get a hold of with their talons. Again, this is something else that'll be easy to clean out. Just give it a pitch when you're done. So that's something to consider. For my purposes, everything's going to be in plastic bins as well, so I don't have to worry about that. Like I said before, I've got my heat lamp here in the middle. I'm going to put a tray underneath in the middle of water, so that the heating element heats the water. That gives it a little bit of thermal mass inside, which gives it a little bit of inertia, and then it'll also evaporate some of that water and create humidity in the bin. So right now, The next step is to get some ventilation in this. So I'm going to put some holes on each side. Not quite sure yet if I'm going to poke the holes or if I'm going to use a hole saw and then glue on some. Sorry. So I'm going to put some holes somewhere near the top on both sides, just so the air can go in one side and come out the other. Eggs breathe through their shells. Black soldier flies respirate as well. They create carbon dioxide that would build up in here and could suffocate the chicks or suffocate the black soldier fly larvae. So either way, we need some ventilation in this. So right now it's going to be set up as a still air incubator. All you'd have to do to get this to be a forced air incubator would be to put a fan inside somewhere, maybe in the middle towards the back, maybe 2 inches off the wall, sitting on the floor so that it circulates air around, which will also force air in and out of the air holes a little better. That's helpful if you're getting too much humidity or you're getting some fungus growing. Circulating that air in there will help with that. For this build so far, I'm really not planning on using that, but we may just show it as an upgrade in the future. Alright, time to make some holes. I use my hole cutting saw to put a 37mm hole, one on each side of the bin, and I just then put some fly screen in here with some hot glue, just like we did with the worm bin. Stuck a little bit better to this than it did to the smooth plastic. So we're ready to go with all the furniture building. Now it's time to look at the electronics. Hey friends, I was going to do this video all in one go, but it seems it's getting quite long, so we're going to break here at the end of the building of the incubator cabinet, and we'll create a second video with details in the electronics. That way, if you're just interested in electronics, you don't have to suffer through all the cabinet building, and if you're just interested in how to make a insulated box, then you won't have to worry about all the electronics. So we'll see you again real soon in part 2.